All right, so today we're going to do a little hyperbolic fitting in the Mala controller app. So we got a data set here. It's actually the same utility. I'm just snaking down it. You can see here we got this yellow line, and we're snaking down the utility, and we're actually going to be doing the hyperbolic fitting right here on that kind of blank spot. So we're going to pull the data back up, scroll back to the hyperbola we want to match on. And a good thing to note here is a lot of times you'll get hyperbolas that have kind of asymmetrical shapes. Um, that's a little bit more complicated to hyperbolic fit on. And so for this video purposes, we're just going to focus on the ones that have a nice, pretty shape to it. I understand it's not always realistic in the field, but it can be a little bit more difficult to hyperbolic fit to utilities that have an asymmetrical shape. So if you can, try to find one that has this pretty nice upside down U shape to it, and that's going to give you your best luck when trying to do hyperbolic fitting. So we will pull out the little filter menu on the side. This is where you have all your options to make changes to the data or put in notes, annotations, all that kind of stuff. But if you notice right at the very top, you have a thing called hyperbola. When you click on that, it's going to bring you up this menu and this menu. So what we do with this one is we click and drag it exactly to the top. And you know, it's going to be difficult to get this perfect. But you just gotta work with it a second. And then we're going to use this slider to change the shape. So what this is doing is it's fitting this. Let me zoom out so you can see this theoretical hyperbola. So if we had a hyperbola up here with this specific velocity, in this case it thinks it's 278, that's what a hyperbola would look like. And if you had it way down here, it'd be a lot wider. Let me zoom out further so you can see how wide it can get. So it's fitting this theoretical hyperbolic shape to the data. And you'll notice even when you see in your data that the hyperbolas up at the top are always a lot sharper and pointier, and then the data that's a little lower is going to come out a lot wider. So we get this back up and centered how I want it to. So let's move this out of the way. We're going to click and drag and bring that right here. And then we're going to fit this. That's pretty close, somewhere around probably 320. I know what the velocity is in this area because I've pushed here a lot. So right around 320, something like that. It looks pretty good. And you know, you can check, you can zoom in a lot more and fit it if you need to be as exact as possible. And you know, this isn't an exact method to get depth, but it's going to give you a really quick and rough estimation. And the more experience you have with this and the kind of the site knowledge, the more accurate you can be. So once that's set, and this looks pretty good, it's going to fit a lot of these hyperbolas because this is a pretty homogeneous soil. And that's something I want to mention real quick too. We'll go over this. So you click check. Now something to mention is if you had in multiple layers of soil, or you had a water table somewhere in here, that's going to cause issues. So anything, the way this works is this hyperbolic fitting is going to average the soil above it. So it's going to average the velocities of the soils above it. And then anything below that could have a completely different shape. So in some cases where you don't have super homogeneous soil, this is good old Charleston. So it had sand down on sand down on sand. The only really thing you have to worry about is a water table. So I know it's pretty homogeneous here. So if you did have something like a layer in here, maybe you want to fit to each utility that changes depth pretty significantly, and fit to that when you need exact depths. But for the most part, most utilities are within 8 feet, and so the soil stays pretty homogeneous within that range. So we'll go ahead and set this, and then let's go ahead and put in a mark. So I'm not going to put it in exactly because I want to show you how to move that and set it. So we're going to click on it again, and then there's a little move, delete, screenshot, photo, audio, all that kind of good stuff. We just want move. Let's click and bring that crosshair right to the center of the first kind of major chunk of the reflection and click check. Fat fingered it, sorry. I'll need to delete this, causing some issues. Check. So now this is going to be set exactly to what we think it's going to be. So 3.98. Another way to do this real quick in our system specifically is to use the AI. And so the AI is going to pretty much auto-populate immediately once you turn your system on. It's going to put these little points in. And I could have marked this all by using the AI if I wanted to. You just change these markers straight over to sewer. It's going to pick it a little higher than I tend to agree with, but for the most part, it's still going to get you in a really good ballpark. So this says 3.69. You know, I was down here in the 3.88, which realistically is just a few inches. And if you're digging for avoidance, calling it a little shallower is probably going to be a little safer anyways. So that's kind of how to do the hyperbolic fitting.